Hey guys, and welcome back to our second lecture on triggers. In our last lecture, we took a look at a before insert trigger wherein we checked some business logic and assigned a primary key based on a sequence, a false primary key based on a sequence object, and then pass those rows on to Oracle Engine for insertion. Really common real world example. In this lecture, we are going to step that concept up a little bit by looking at a parent-child or master-slave relationship, classic dependent relationship in the database. We will again look at using a before insert trigger to assign a false primary key to the parent row based on a sequence object, but then we are going to have to take a look at some new strategies for assigning that child segment primary key. If you'll recall your database designs classes, when you have a parent-child like that, the child primary key is made up first of the parent key, primary key segment, and then typically a sequencer. So, for example, say you've got a sales order line table, classic parent-child relationship. The primary key of the sales order table might be the value 10, then the primary key of the rows in the child table will be 10, 1, 10, 2, 10, 3, and on and on and on. The trigger for that child table is a little bit tricky, and we want to take a look at how to do that kind of trigger in a sane fashion. Again, classic real-world example, because we're going to find dependent relationships in the database every day. And I'll cut right to the chase. What we're going to talk about here is mutating triggers. Put too much logic, do too much in your triggers, and they begin to mutate, and you get a mess. Ultimately, how do we resolve this issue? We pull that logic out of the triggers and put it into packages where it belongs, and that's the example we're going to look at here. All right, let's go ahead and jump inside and take a look at some code. So lecture 8 script.txt, open her up and let's jump inside, see you there.
All right, let's start out by building ourselves a couple of tables. I've very cleverly named these guys master and child. As I mentioned in the introduction, this is a very common schema design configuration. Sales orders, purchase orders, partial shipments, tons of these guys in nearly every design. We're going to talk about how not to mutate their associated triggers. While you're at it, please also build a sequencer for the master table in a fashion similar to our example in the last lecture. We'll use that guy to assign values to the master table false primary key. Again, standard stuff. All right, we start off easy by writing the before insert master table trigger. Really straightforward stuff here. All we do is read the next value from our sequencer object into the new master PK field and then pass our new rows over to the Oracle Engine for insertion. As a means of saving time here, I'm not going to test this trigger on the premise that we proved its worthiness in our last lecture. Let's just assume you did a single row insert with commit. All right, now let's move on to our first attempt at a trigger on the child record. The child record will of course contain the same initial segment value as the parent record and then sequence the second segment of that primary key. Again, very standard stuff. This is everyone's first attempt at that trigger. Clearly compiles, and if we test it on a single row insert, it behaves just fine. Set the child sequence value to max +1, where master segment equals new master segment. If this is the first insert for this master segment, set the child segment to 1 based on null. Easy peasy, right? Well, not so fast there, Mario Andretti. We haven't tried our trigger yet on a multi-row insert. Oh no, the old dreaded Aura 04091 table is mutating. Guys, that is never good news. Here's the definition. A table will mutate when you perform any DML on that same table either directly or indirectly via transitivity. Why is this bad boy mutating? Because we're performing a select on that table inside our before insert trigger, i.e. we are performing a DML statement directly on the triggered table. By the way, what would happen if we select from table B, which updates table C via trigger, and then table C ultimately reads from the original table? Yes, you got it, buddy. Mutation. This time indirectly via transitivity, and I don't care how deep you run the transitivity, Oracle's going to catch it. So you say, hey, Rick, I need that child sequence value. How do I get it if this trigger is going to mutate on multiple rows inserts? Certainly, I don't want to put this back on the hands of the 3GL programmer. Good question, and you have to figure out, I wouldn't have used this example if I didn't have an equally elegant solution. Let's start off with a package definition. Packages are going to be discussed in detail in lectures 13 and 14, but for now, let's just agree that packages allow us to collect a bunch of subroutines and their associated data structures into a single location, and then make them available to users in a nice, neat solution. We'll build them ourselves, and we'll also study those supplied to us by Oracle. For now, let's just build a really simple package and then its associated package body. First thing to know is that packages are made up of 2 components. The white box piece exposes a known signature to the outside PLSQL calling world. Here our little package is called number trigger rows and exposes 3 subroutines within its white box signature. The 4th element in this package, the nRows variable, is a package-wide global variable and is used by each of these 3 exposed subroutines to count the number of rows processed by a trigger. A package body serves as the black box component of a package. Whereas the package definition exposes a signature to the outside world, the package body definition hides these black box contents and the associated logic from the calling PLSQL world. Net, you got some business logic secrets you don't want to make available to the PLSQL calling world? Put it all inside the package body black box. All right. Let's not get too crazy at this point over the body contents, but I think things are pretty self-explanatory. Looks like our number trigger rows.init count subroutine does nothing more than sets our counter to 0. Then the cleverly named add1 routine increments our counter, and the equally aptly named getRows function returns the counter value to a calling piece of PLSQL code. All straightforward stuff. We can now update our before insert child table trigger to increment the package counter on each entry of each row, and then reads that same counter into the child sequence PK segment. We now try our multi-row insert, and ta-da! We just inserted multiple rows into the child table with the appropriate child sequence segments without mutating. All right, great, you say, Rick. But what happens when you're in a multi-user environment? What about 100 people all banging on that child table concurrently? Well, our little package here was obviously too simplistic for that kind of solution. However, what if you used a local record structure in that package that contained a table name, a username, and then our counter for each of those combinations? Think about it. All of a sudden you have a generalized, yet really elegant method for child sequence numbers all within a black box package. We don't have the time here, but as a fun exercise, you may want to write that package and put it up there for everybody to share with your colleagues, students.
Okay, guys, welcome back, and I hope you enjoyed that. That is pretty much what I would consider the classic trigger issue. I want to go beyond just enforcing some business logic and assigning a primary key, false primary key, to actually doing some more interesting stuff. In our case, assigning the next available sequence value for the child primary key segment. When I did it through a select null max plus 1, comma 1, it worked just fine on a single row insert, but blew up when I did it on a multi-row insert because the trigger started to mutate. That is, I was performing a data manipulation language action within my trigger that ultimately impacted the same table on which that trigger lived. That mutation will occur whether that is direct DML or even indirect. That is, I in trigger on table A, impact trigger on table B, activate trigger on table C, which ultimately comes back to table A, and I mutate. Now I've got the whole entire database mutated. It's bad stuff. How do you avoid it? Real simple. Take that DML out of your triggers and put it in a package where it belongs. Very common practice and a great real world example in that we learned how to avoid mutating triggers. What's the chase? Keep the logic in those triggers really, really simple. And when you need to add more sophisticated logic, pull it out and stick it in a package where it belongs. All right, we're going to study packages more in depth further down the line, but for now, that pretty much wraps up this lecture. In our next lecture, we are going to start looking at procedures. Should be great fun, and I'll see you there. In the interim, you know my gig. You go out there and you have some fun, but learn something new every day because it's what's important. Catch you later.